Objective 5, determining the density of any gas at STP or determining the molar mass of any gas given its density. The density formulas, maybe perhaps you'd like a little margin note here. The mass over volume is our density. Density is defined as mass over volume. Mass for us is the term molar mass. How heavy is it off the periodic table, just adding weights? Volume is determined as molar volume, and that's always 22.4 liters. Always, always a gas at STP. Density is defined as molar mass over molar volume, where molar volume is always a constant 22.4 liters. So D is equal to M over V. Sometimes I hear kids with this little saying, density equal love. And what that happens is if you manipulate this, you can kind of make a little heart-shaped density equal love, M over V. See the heart there? Mass over volume. So let's take a peek. The density of a gaseous compound, it contains carbon and oxygen, is 1.964 grams per liter at STP. We do not know the compound. It's just made up of C's and O's. We'd like to determine the molar mass. Given density, the constant of molar volume, we'd like to solve for molar mass. So that's the variable I cover up. D times V will show us the pathway to find molar mass. We'll start by writing the number, 1.964 grams per liter. We can't write a label because we don't know the compound. We know it's made up of C's and O's, but we don't know the formula. So I have to leave that label out. 1.964 grams per liter is the density. We want the liter to cancel, so the liter has to go on top. Density times the molar volume of 22.4 liters. You can set that over a 1 if you'd like to. See that in that way? And what's happened? We've managed to cancel liters and convert our density into a gram, the unit for molar mass. So molar mass can be determined by hitting 1.964, that's our density value, times the molar volume of 22.4, and we've converted to find it 43.99 grams. This is made up of C's and O's. I know that carbon weighs 12, oxygen weighs 16. Kind of thinking about manipulating to find a formula. 12 and 16 added together gives us 28. Our target of 44 leaves us 16 short. So 1 carbon and 2 oxygens would work to find the formula that weighs 44 grams for its molar mass. 43.99 or 44 grams of carbon dioxide. Density times molar volume found our formula weight, and just playing with the weights of C's and O's, 1 carbon with 2 oxygens added to that total of 44, our target. Question 2. What's the density of argon at STP? Well, argon off the periodic table is Ar. Argon has a formula weight of 39.948. I can call that 40. The molar mass of argon, 40. We know that molar mass divided by molar volume pulls out density. Density equal love, mass over volume. For mass, we'll use 40. For volume, it's the constant 22.4 liters. So the density can be found by taking the molar mass, which is 40.0 grams, and we're going to divide that by the molar volume, 22.4 liters, and literally our unit ends up to be grams per liter. That's our desired unit for density, grams per liter. So the molar mass of 40 divided by the molar volume of 22.4 gives us a density of 1.79 grams per liter. So again, molar mass over molar volume pulls out density, mass per volume. Question 3. The densities of gases A, B, and C are respectively 1.25 grams per liter, 2.86 grams per liter, and 0.714 grams per liter, respectively. Calculate the molar mass of each substance, and then identify them as either ammonia, NH3, sulfur dioxide, SO2, chlorine, nitrogen, or methane. So the first thing we'll need to do is identify their molar mass. We've got some calculating for gas A, for gas B, and for gas C. Let's take those densities, which were 1.25 grams per liter, 2.86 grams per liter, and 0.714 grams per liter, respectively. We'll use the molar volume of 22.4 liters. You just set that over a 1 if you'd like. Density times molar volume pulls out the molar mass. So one at a time, I've just written each density. For gas A, it was 1.25. Gas B, 2.86, and gas C was 0.714. Each one of those will now get multiplied by the molar volume to find the molar mass. D times V pulls out mass. So let's hit for A together. Density of 1.25 times the molar volume of 22.4. This is 28 grams for gas A. Gas B, 2.86 times 22.4, density times molar volume, and this is 64 grams for gas B. Gas C, we have density of 0.714 times the molar volume of 22.4, 15.99, I'll call that 16 grams for gas C. We now have a choice, a bank here. We have ammonia, NH3, sulfur dioxide is SO2, chlorine is Cl2, nitrogen, N2, or methane, CH4. Let's just go to work and add these formula weights, and they're going to match. Somebody over here weighs 28, somebody over here weighs 64, and somebody over here weighs 16. Let's find it. Well, nitrogen, I can see weighs 14. 3 more for the